Welcome to my tutorial on using C and NASM assembly with Python. So Python allows you to use C through the use of DLLs, and C allows you to import assembly functions and use them. I did that in my previous video, which should be linked in the description. In that video, we created this core.obj file, which you'll need for this tutorial. Okay, so to get started, let's make some files. We'll call them interface.c, lib.py, test.py. In interface.c, we're going to import all the functions from core.obj. Then we're going to compile it into a .dll file. In this lib.py file, we're going to use a Python library called ctypes, and with that we can call the functions from the DLL, so call the assembly functions. In test.py, we're just going to test everything out. We're going to also compare its speed against Python speed, so you can really see the difference. Okay, so to start, in interface.c, we're going to just add the function declaration for factorial, right here. Then, right over here, we're going to make it into a .o file. So gcc c interface.c -o interface.o. If you don't put the C flag, GCC will complain, like, where's the main function, because it's expecting it to become an exe file, but we just want a .o file, so make sure you set the C flag. Now we have interface.o. Now we're going to use another GCC command, gcc shared interface.o core.obj. You just put all the files you want for the linker to make it into a DLL, and in this case we want interface.o and core.obj. Then we're going to set the output to be interface.dll. You can name it with whatever you'd like, but just make sure that the file extension is .dll. There. Okay, so in lib.py we're going to import this library called ctypes. Yeah, by the way, you can delete this interface.o file if you don't need it anymore. Yeah, so first we need to get the DLL into a variable. So how you do it is instance this class called cDLL, and in the constructor just specify the path to the DLL. So in my case it's interface.dll. This should load the DLL up into there. So one thing you want to know is that C integers, like int, and Python integers are completely different. C integers, you have to worry about memory, they have a limit. Python integers, they can go pretty high. Now, because of that, we need to specify the return type and arg types of this factorial function. So you do that with interface dot and then the function name, in my case factorial, dot arg types, and then arg types is a list of the argument types. So since factorial only takes one argument, it'll just be a list with one element in it, and you can't just put int because that's a Python int. You have to put C_int. Similar thing for the return value. So it's a type like that again, and it's not a list. So it's a C_int also for me because factorial takes int, returns an int. Now we have to sort of define the function in Python, and it's just a wrapper that calls this function from C, factorial, and that calls it from assembly. So we're gonna make a function in Python called factorial, takes int, returns int. So calling the functions from the DLL is pretty straightforward. You do interface dot and then function name, again factorial. Then you just pass in the arguments directly, and I'll return whatever it returns. So yeah, this is all for lib.py. Then in test.py, let's import it. Now just to make sure it's working, try printing factorial 5, and this should print 120. Yeah. There we go, 120. Now, let's just test the speed of Python versus assembly. Yeah, I know there's gonna be a difference, but I'm just gonna illustrate my point. I'm gonna show you. So we're gonna make a Python function for factorial. Takes it, and we're gonna code it the same way we coded it in assembly. So result equals 0 while n is greater than 0. Result times equals n minus equal 1. Return result. Okay, and again, make sure your function works. 5 should be 120. No. While n is greater than 0. Okay, so first time around, it's 5. It's greater than 0. Oh, I have to multiply. Yeah, you can't multiply by 0. There we go. Yeah, 120 now. Now we're gonna import this function from time. Import time. We're gonna use it to measure the speed. So we'll do time before Python is equal to time, call the function, then print pi factorial 9999. Then time after pi is equal to time, then print the assembly factorial 9999. Then time after assembly is equal to time. Now let's just print the results. Time Python time which is equal to time after pi minus time before pi. Then similar for assembly. ASM time after ASM. Now we could do subtract it by time after pi, but just to make it look better, we'll do time before ASM is also equal to time minus time before ASM. There we go. Now it's gonna give us an error that this integer is too long, I think. Let me see. Yep. So we have to import this function from sys called this set int max string digits. Then we have 9999, so just add 1 to it. It should work. Okay. There we go. So yeah, you can see factorial 9999. It's a pretty big number. Now, although Python is pretty fast, you can see that it took 0.03 seconds, whereas assembly took only 0.0001 seconds. And that's a lot faster. Yeah. Thanks for watching my tutorial on using C and NASM with Python.